Okay, so how do we do these other problems? Look, again, it's all to do with position. Now tan is slope. I have a slope of 3.4. Well, slope of 3.4 kind of looks like that. If I were to draw my slope triangle, it's going to be 1 and 3.4 like that. And on this side of the circle would be -1, -3.4 is my positions. It says find the sine and cos trig ratios here. Well, I need the hypotenuse here, or the radius. To find the radius, I need to use Pythagoras. So I end up with 1 plus 3.4 squared. Okay, and then I'm going to square root that number, and I get approximately, and again, I don't need exact values since these are decimals to start, so I'm going to use a decimal value of 3.54. If I want to find the sine and cos ratios, I would just go sine theta is equal to sine is vertical, and it's going to be over 3.54, and I'm going to call this one theta 1. Okay, so 3.4 is going to be 0.959. Now, it could have been in the other direction though, and I'm going to call that one theta 2. Okay, so this one's going to be theta 2. I'm going to draw this triangle in green here, because that could also been the theta 2. That's going to be -0.959. Okay, so there's actually two possibilities here because we don't know. It doesn't tell us it's a quadrant. We have no idea. So that's why it says draw the angle with an S. Okay, so then I want to do cosine. So I'm going to do cosine of theta 1. When I look at the picture, cosine theta 1 is going to be 1 over 3.54. So 1 divided by 3.54 is going to be 0.282. Okay, now again we have to consider that, well, we don't know if it's in quadrant 1, it could be in quadrant 3. So if we want the cosine of that angle, of theta 2 angle, we would have to go in the opposite direction. Okay, so it will be -0.282. Okay, so there we do have to, again, this is an issue where we have to consider two possibilities. Okay, we're given the tangent, which means that we have slope. That slope, since the quadrant is not defined, we have to be able to consider both possibilities. And then we get these two sets of answers for the sine and cos ratio, because we don't know if we're talking about sine and cos of theta 1 or sine and cos of theta 2. Okay, so this one here, again, we're using position. XY position, -2, -9, maybe something like that. Okay, it locates that coordinate locates that position. And I want to find exact values for cosine and tan and the angle. Now the quadrant is known. Although I have to consider two different positions, because the position is fixed, I'm only going to give one answer. Here I've given two because I wasn't quite sure which position I was at. Here I know for a fact I'm in quadrant 3. So I'm going to use Pythagoras to get the hypotenuse or the radius. I want to find the sine, cos, and tan. Sine theta is going to be y. Sine goes with y. And again, notice I'm using exact values. I don't use decimals here. Okay, the tan value is my slope. It's going to be negative over negative, so it's going to be positive slope of 4.5. Hey, I want to find the angle. Okay, so I'm going to find theta 1, and I can use sine, cos, or tan. I'm going to use sine this time. I'm going to use the sine ratio and then undo the sine ratio with arc sine. That's the opposite. And when I do this on my calculator, I'm going to do arc sine -9 divided by square root 85. I get -77.747 degrees. So -77 I'm going to round that to 5 degrees. I've got a problem again. That's in the wrong spot. Okay, so theta 1 is in the wrong spot. It's negative 77.5 degrees. It's over here. I don't want that spot. However, I can kind of tell that this to do with the same symmetry. Okay, your calculator can't tell which quadrant you're in, but we can see that although we're in the wrong quadrant here, I can get that position using symmetry. So I'm going to start at 180 degrees, and I'm going to go the opposite. Instead of going negative, I'm going to go in the positive direction. So I'm going to go in this direction. So I want theta 2, and that's going to be 180 degrees minus the position of negative 77.5. Now, some of you may just say, well, I'm just going to add 77.5. That's fine. But here, I'm using negative 77.5 as the position angle, and using that position angle to calculate the position of the theta 2 there. Okay, so there's my theta 2. It's going to be 247.5 degrees. Sorry, 57.5 degrees, I think it is. Yeah, 257.5 degrees. Okay, so again, the position is important. If I know the position, I can, although I'm getting two possibilities here, okay, my calculator gives me one, I can figure out the other possibility based on the symmetry. Last thing is the secant, cosecant, and cotan. Now this isn't really something that we need to worry about right now, but the secant ratio, all it is a reciprocal of cosine. So I'm just going to show you that the reciprocal of cosine is just going to be the cosine ratio flipped upside down. The cosecant is just going to be the sine ratio flipped upside down. And the cotan ratio is just the tan ratio flipped upside down. Okay, so these may be new to you. You may never seen these before, but all these really are just the primary ratios, but they're reciprocals when we flip those ratios upside down.